In early February, not too long before the COVID-19 pandemic sent most of us home to telework, we were in something called the Mars 2020 conference room in Los Alamos. There were a half dozen or so scientists sitting at a table, eyes glued to their laptops and two large screens in front of them.
Watches to cover target 2, and
I think you have to do that at SCL.
Opportunistic supercam added to the morning block.
The screen showed an alien-looking landscape and the rough, shadowy outline of Perseverance, the newest rover sent on a mission to Mars. Voices from around the world were checking in over the speakerphone, reading off data points and updates.
Current capital plan is to heat up to the top.
But the images on the screen weren't from Mars. They were beamed straight from a California desert. A cutout stood in for Perseverance. The real rover was thousands of miles away, preparing to be launched from Cape Canaveral. This was a simulation, one of many that the teams have performed before the real thing. Now, the real thing is just days away. Perseverance is ready for launch. I'm Lexi Patronis from the Los Alamos National Laboratory Public Affairs Office. Over the next few weeks, we'll be talking to some of the people on the elite teams behind specialized instruments on the Perseverance rover that will capture images, sound, and brand new data from the red planet. Welcome to Mars Technica. Los Alamos National Laboratory is responsible for several parts of Perseverance, including SuperCam, which will analyze Martian rocks and soils with a camera, lasers, spectrometers, and a microphone. To fully understand what we're trying to learn about Mars with the launch of Perseverance, we have to go back to what we already know.
My name is Roger Wiens. I am the principal investigator of the SuperCam instrument. It's a laser instrument that sits on the top of the Perseverance rover. Here at Los Alamos, I'm a scientist and a team leader in the planetary exploration team.
I was reading a story with you where you talked about I think when you were 7 years old, you were, gazing out into space. And I was curious if you might be able to tell us that story about your first sort of looking out into the galaxy.
My brother and I were very fanatical about everything that was space or rocketry when we were kids. And so we started building and launching model rockets, made a whole arsenal of these. But the other thing that we were really known to do at that time was to be into astronomy. And we, in fact, both joined the American Association of Variable Star Observers. I think they had no idea that we were kids. And this is an amateur astronomy organization that actually contributed data on the brightness of different stars. And then we went on and got a telescope. Actually, we built the telescope. We bought the parts. One part actually came on a train. That was the tube of the telescope, and we built this up from the mirror and the tube and so on. We didn't have enough money for a stand, and so we put a fence post in the ground, and we carried our telescope out and put it on the fence post. We got it done just in time for the close approach of Mars, at which point we could actually sketch features on the red planet for our enjoyment, and we could watch different phases of not phases, but different parts of the surface of Mars appear before us as we went out different nights.
Wow. Do you still have those drawings?
We started looking for them about 10 years ago, and we never found them.
So, way back in the day, there were some early perceptions of Mars that were very different than, what it turned out to be.
150 years ago now, Percival Lowell and also Giovanni Schiaparelli started doing intensive observations of Mars. And you can really do these every 2.25 years when Mars approaches Earth or when Earth approaches Mars. Actually, as is happening this year in 2020. And so they were looking just like my brother and I were with the telescopes and trying to discern what they could see of the surface of Mars. They thought they could see canals. You're looking through an atmosphere that is turbulent here on Earth, and so you see these dark features on the surface of Mars. It's great. It's just wonderful if you get the chance to see Mars through a telescope this year. And but sometimes these parts of Mars kind of blur as the air turbulence comes over us, and they thought they could see kind of points or lines connecting some of these dark features. And that made them think that there could be creatures living on Mars that created canals to shuttle water from one place to another. So this was, they were very serious about this. The first spectroscopy of the Mars atmosphere around the turn of the 19th to 20th century kind of told us that Mars really didn't have oxygen and didn't have much of an atmosphere. So the leading scientists were saying this cannot really be credible, but they persisted in this, Lowell, up until about the 1920s when he passed away. But it really took until the 1960s when we were able to orbit and fly by first with spacecraft and then orbit Mars in 1970 that we really saw what Mars was like and could really confirm that there were no living creatures on Mars. And in fact, you could say this persisted all the way to the Viking landers in the 1976-77. And actually, at that time, when the first landers were successful on Mars, Gerald Ford was president at the time. He called up Larry Martin, the project leader of Viking at the time, out in Jet Propulsion Laboratory, and wanted to talk to him. First of all, Larry Martin told him to call back because he was busy, which is unthinkable to a president, but he had the gall to do it. But when they did arrange a call and a talk and a discussion together, Gerald Ford actually asked the question, would you see anything moving on the surface of Mars? And Larry answered back, do you mean like something that's living? And he said, yes. So they said, well, we can tell by taking successive pictures that something has not moved. And so that was kind of the end of any ideas that there could be any bushes, any organisms that were of any size at all. And the Viking landers also had organic tests, and those did not show up positively. So that was kind of the end of that era of thinking that there could be life of at least of some advanced form on Mars.
And so that brings us to your work. The work, in this case, are instruments aboard Perseverance that will help the rover with its overall mission to seek signs of ancient life and collect samples for possible return to Earth. These intricate instruments involve thousands of hours of work, multiple countries and agencies, and hundreds of people. And through the course of this podcast, we'll talk to many of them about the fascinating details of their work. We'll talk to Roger again soon, too, and take a guided tour of SuperCam. But first, meet Nina.
I'm Nina Lanza. I am the team lead of the Space and Planetary Exploration team, and I'm also a scientist working on both the ChemCam and SuperCam instruments.
You're double cam.
That's right, all the cams.
So now what brought you to the lab?
So I came to the laboratory first as a post-baccalaureate student. And I came originally because I was, and I'm a little embarrassed to admit this, I was following my then boyfriend, who was working at Los Alamos as a graduate student. I didn't know anything about Los Alamos, but I figured let's give this a whirl. We got married, so I think it worked out. It's good. When I first came here, I was just out of undergraduate and I had a degree in astronomy. So I figured, well, let's see what kind of work they're doing here. And I happened across an article about Bill Feldman, who is a very well-known Mars scientist here at the laboratory and across the world. And I didn't really know any better because I was 22. So I just called him every day for 2 weeks until he hired me as a post-baccalaureate student. So thank you, Bill. That's how I got my start on Mars. I had always been interested in Mars. I had just seen all the results from the Pathfinder mission, which had landed in 1996. And there were these beautiful images. And I just thought to myself, I want to do that. But I had no idea how I was going to do that. And so Los Alamos was my very first step towards that.
As the scientists anticipate the launch of Perseverance, which can happen any time between July 30th and August 15th, it's clear that's exactly what it takes to get this far, perseverance. But another name for the rover, and space exploration in general, might as well also be patience.
these missions are really exciting and I think are in the public eye right when we launch and when we're landing, but I think it's easy to lose track of them because they last a long time, and that's good. And the process of science is actually pretty slow. Right now, we're actually revisiting some of the data that we already analyzed years ago, right? There is a place that we were on Mars in 2013 that I actually wrote a paper about. But now I'm like, well, did I get that right? What do we know now after years of exploring this? Should we revise our statements? And that is something that I think is the public doesn't always understand. Like, we do our best with the knowledge we have, but we have to constantly revise what we know in the face of new information. But that is exciting. That's really good. We get a better understanding by taking our time. A lot of these missions too take a really long time to plan, to actually just get to Mars and then to get data. So it's going to take a long-term investment and excitement, but it's so worth it because, we're going to be getting samples back from Mars. And people don't realize that we actually have never done a sample return from Mars. Like, all the samples that we have from Mars are meteorites that fell onto the Earth, which is super exciting. It's something like 150 that we've identified, okay? Those are all rocks from Mars that came to us, which is very convenient. But as a geologist, I can tell you that, since we don't know where they came from, it's really hard to put any context in them. So it's as if you just like drove somewhere out into the desert, opened your car, just like grabbed a rock and then like ran, and you just didn't even take a picture of where you were. And so what could you tell about that place where you stopped the car if you just grabbed one rock really fast? You would have a little bit of difficulty telling the story of the geology of that area. That's what meteorites are, and they're super helpful because it's more than nothing, right? We've learned something about Mars rocks, but gosh, wouldn't it be great to have a sample from a place that we knew where it was from and we could pick it? That's what we're going to be doing in part on Mars 2020. Perseverance is going to be caching samples so that we can go get them later and then analyze them in the lab. And that's going to be revolutionary. It's just going to take a long time. And so people are going to forget about it. And I just urge you, don't forget about it. It's going to take us a while to do it, but it's going to really fundamentally change our understanding, not only of Mars, but also probably of Earth. We started Mars and Earth as very similar bodies, and now we're so different. How did that happen? And getting these samples from Mars can really help us understand not only, what has happened on Earth's past, but also what might happen in our future.
Mars Technica is produced by Los Alamos National Laboratory. Joey Montoya is producer and editor, Lexi Petronas writer and host, with special contributor Laura Mullane. An additional thanks to Scott Falk, Charles Poling, Camille Dixon, and Arthur Bishop. Find out more about the laboratory and its mission at www.lanel.gov.